Hello P3, I hope you're having a good Friday so far today. As I told you on Wednesday, what I'm going to do for you today is do a quick review of page 20, notes that we talked about on Wednesday. We're going to finish these last three problems together on this page so that you can remember what to do, and then you guys are going to do your practice assignment today in class, okay? So follow along with me as we review notes and finish the three problems on the right side, and then you guys are going to get your period in order to be able to do your practice assignment, okay? So on Wednesday we talked about that we are learning systems of equations now, and a system of equations is just two or more equations that have the same variable. So for us, all the equations have x and y. To solve, when we talk about the solution to a system of equation, if you're talking about the graph, we're looking at the point where the two lines intersect or cross, which would be like right here. If we're talking about algebraically, it is the numbers x and y that would make both equations true. We would be able to put the same number for x here and x here, and y here and y here, and when we do the math, both equations would be true. That's what makes the algebraic solution. And we talked about how there are three types of solutions, just like when we had a single variable equation. If you have parallel lines on your screen, then you're going to see no solution. If you have two lines overlapping each other, that's infinite solutions. And if you have two lines that intersect, this indicates one solution, and the solution is the coordinates of that point where they cross. And you have to put this whole thing. We're no longer just looking for the x number, because remember, in these equations we have x and y, so we have to say what both numbers are equal to. And we said that the way to do this is, if needed, we'll change our equations to slope-intercept form. Then we'll graph the lines, and then we'll identify the solution using Desmos. So we want to do for today, for today's activity, and the notes and the practice page, we're going to do this by hand because we need practice with this. But next week we'll take this part out and we'll just use Desmos, okay? So we did a whole bunch of them together on Wednesday. We found most of them had one solution. We had this one with infinite solutions, and we've got three more here to go. So let me zoom in a little bit closer. Join me please on number 6. So our first equation is in slope-intercept form. It says y equals. So I can identify my slope. Remember, the slope is the coefficient of x, which in this case would be 1. So our slope is 1 over 1. And our y-intercept is 5. And to graph, remember, we start with the y-intercept. So I'm going to go to the y-axis. I'm going to find where 5 would be. Here's the origin, 1, 2, 3, 4, 5, and that's where my first dot is going to go. Then I'm going to use the slope to find the second dot. Remember, slope is rise over run, so I'm going to go up 1 and over 1, and since this is positive, I'm going to go up and to the right. Then I'm going to take my ruler, and I'm going to connect my dots. So there's the first line graphed. My second equation is not in slope-intercept form. This is standard form, so we're going to have to change it. So you're going to recopy it carefully and draw your line of death. In order to get y by itself, we need to zero pair the x. So since this is a positive x, I'm going to put minus x underneath. You can cross out the zero pair. Be very careful here. We're not bringing down y, we're bringing down negative y. And then on the other side, we'll have negative x plus 2, because that's a positive 2. Now, this is not good enough because I don't want negative y, I want positive y. So I have to divide everything by negative 1. The two negatives make a positive, so that gives me positive y. These two negatives also give me a positive, so that's going to be positive 1x. But 2 divided by negative 1 is going to make negative 2. So there's my new equation. My slope again is 1, so 1 over 1. And my y-intercept this time is negative 2. Now I want you to think for a second. The first equation had a slope of 1. The second equation also has a slope of 1, but they have two different y-intercepts. I want you to think for 1 second and make a prediction. Do you think we're going to have one solution, no solutions, or infinite solutions? Well, let's find out. Our y-intercept is negative 2, so this time I'm going to go down to negative 2. And my slope again is 1 over 1, so up 1 and over 1 to the right. Connect your dots. And you have a lovely set of parallel lines. So if you said no solution, then you were right. Now remember that what we want to do is we want to verify in Desmos that we actually did this problem right. You have this tool that will basically show you your answer and you'll know if it's right or not, so you should use it. And what you do is you go back to the two original equations and you type them both in and you look at your graph to see if it is the same as what you drew. And you can see that indeed we do end up with two parallel lines, so we were correct, and we do have no solutions on this graph, for this system rather. Okay, let's go down to number 7. My first equation is in standard form, so we're going to have to change it. Don't write too big here because it looks like we have to change the second one too. Copy it carefully. In order to zero pair the 3x, I need to do minus 3x. The 3x's cancel out. Be careful right here, you're bringing down negative 5y. And these are not like terms, so I have to keep them both, negative 3x minus 35. In order to get rid of the negative 5, we're going to divide everything by negative 5, not positive 5, negative 5. These two make a positive 1, so that's 1y. If you go into Desmos and do 3 divided by, or negative 3 divided by negative 5, you're going to get a decimal. When you change it back to a fraction, you get 3/5 positive. So that's positive 3/5 x. And then in Desmos, if you do negative 35 divided by negative 5, you're going to get positive 7. So plus 7. Our slope is 3/5, and our y-intercept is 7. Feel free to pause me anytime that if I'm getting ahead of you and you need me to slow down for a second, you can just hit pause. So to graph this, I need to find my y-intercept of 7. So from the origin, 1, 2, 3, 4, 5, 6, 7. My slope is 3/5, so up 3 and over 5, and it's going to be positive. So up 3 and to the right 5, which is right here. And then you're going to make your line. Then we need to look at our second equation, which is also in standard form. Bummer. So we're going to have to change this one too. 2x plus y equals negative 6. So put that down here. In order to zero pair 2x, we'll do minus 2x on both sides. We'll bring down the y, and this is going to be negative 2x minus 6. And we already have y equals, so we don't have to do anything else. My slope is negative 2 over 1, and my y-intercept is negative 6. So we're going to start with our negative 6 on the y-axis. So this time we're going to go down 6, 3, 4, 5, 6. Our slope is negative 2. That means I know that my line has to angle this way. So I can either go up and to the left, or I can go down and to the right. Whichever way you want to go, that's going to make you happy. But that will just make sure that your line is tilted in the right direction. And you will have a line that looks like this. Remember, the intersection point is the solution, so we have one solution here. And to find out what the solution is, we're going to use Desmos for this, because the graphing will be more accurate than the lines that we've drawn. I went ahead and typed in, and remember guys, you're typing in the original equation. Don't type in the equation that you figured out, because what if you figured it out wrong? You want to go back to the original, type the originals in, and then you'll be able to tell if you did this right or not. So let me move this over a little bit. I think this looks pretty good. Looks about right to me. So we go to the gray dot, and our solution is negative 5, 4. So remember, you have to put the parentheses, both numbers with a comma. We're saying that x is negative 5 and y is 4. And we have one last one. Our first equation, x equals negative 2. Remember that if you only have x or you only have y, that means you're going to have a horizontal or vertical line. If it says x equals negative 2, you go to the x-axis and put a dot on negative 2. And then the x-axis goes this way, so you turn your ruler perpendicular, and this is the way that you're going to draw your line. It's a vertical line. Our second equation is, it's in standard form. We're going to have to change it. 3x, be careful copying. That's a negative 18. In order to zero pair 3x, I need to do minus 3x on both sides. We're bringing down a negative 2y. Be careful there. These are not like terms, so I need to keep them both. Negative 3x minus 18. And I need to get rid of this negative 2, so we're going to divide everything by negative 2. And these will cross out and give us 1y. In Desmos, 3 divided by 2, well, negative 3 divided by negative 2 is going to give you positive 1.5, and when you change that back, it's going to be positive 3 halves. So 3 halves x. And then in Desmos, if you do negative 18 divided by negative 2, that's going to give you positive 9, so plus 9. Our slope is 3 halves. Our y-intercept is 9. So start with your y-intercept, go to your origin. We're going to count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And I'm supposed to go up 3 and over 2, but I can't because I'm running out of space. So let's think for a second. I'm going to have to go down 3 and over 2, but do I go right or do I go left? Well, this is a positive slope, so I know that my line needs to go like this. So if I go down, I need to go this way, to the left. If I go to the right, it'll be going the wrong way. So down 3 and over 2 that way. 1, 2, 3, 1, 2. And we'll connect. And this is clearly one solution, which is right here. And we can bring Desmos over. I typed this one in already for you. Let me see if I can slide this. You can see it. So we have our vertical line and we have our angled line, and they are connecting right here, intersection. So -2, 6 is your solution. Okay. So this is what your practice is going to be. You guys, just as a side note, I love doing these kinds of work because I look at this page and I'm like, man, I did some math today. Look at all this. Like, I did some math. I know I did some work today. It looks good. Here is the page that you're going to do. It is called Homework 1. This is a different homework, not your homework that I give you. Make sure you put your name on it so that I can get it back to you after I collect it. And you're going to basically have 1, 2, 3, 4, 5, 6, 10 problems like we just did, where you are going to change your equations if you need to, graph them, and then use Desmos to check and clearly identify your solution. So there's not a box on here like there was before, so you're going to have to write one solution, no solutions, infinite solutions. And if it's one solution, remember to give me the coordinates of the point, okay? And then you're also going to answer these 3 questions. And the questions are asking you about what the lines look like. If a system of linear equations has one solution, what does this mean about the 2 lines? What do the 2 lines look like? If a system of linear equations has no solution, what does this mean about the 2 lines? What do the lines look like? And if a system of linear equations, this has actually 2 linears in it, of linear. If a system of linear equations has infinitely many solutions, what does this mean about the 2 lines? Again, what do the lines look like? So you're just describing what you would see on the graph, okay? So your job is to do this as accurately as you possibly can. The answer key, the sub has my answer key, and so it will be up on my desk for you to come and look. I would recommend, if you are not sure about these, I would do one at a time. Go check it. Do one at a time. Go check it. If you feel pretty confident, maybe to do 2 or 3 and go check it. But I wouldn't do the whole thing and then check them all. Then you would have a lot of errors that you might have to go back and fix. I hope not. Whether or not you finish this today, I want you to turn it in. So if you finish it early, great. Put your name on it and hand it in. If you don't finish, if you get to the end of the bell and it's time to clean up and you're not done, put your name on it and turn it in anyway. It's not for a grade. I just want to look at it. I want to see how far you got, and I want to get an idea of everybody's level of understanding. And the only way I can do that, since I'm not here with you today, is to actually look at your paper. Okay, so please turn it in. I will give it back to you when I see you again next week, but I do want to take a look at it. Okay, so this is what you're doing. If you finish this and you have time left over, you could do the homework paper that I gave you, and because it's due today anyway, get that turned in. That'll be your first grade of the marking period, so let's go ahead and do that on time. Okay, I hope you guys have a great weekend, and I will see you next week.